wonder what kind of operations can we perform on complex numbers? And the answer is all of them. So let's start with the most fundamental one, which is addition. When we add two complex numbers, a plus bi plus c plus di, we add the real parts and the complex parts. So this becomes a plus c plus, now here are my imaginary parts, b plus d I. When we subtract, we do the same thing. A plus bi minus c plus di. And my mouse is really behind my words here. Then, let me catch up here. Then we're going to take this negative sign, distribute it to both of them. We're going to collect our real parts. So this is a minus c, that'll be my real part, plus b minus d I. So suppose I have, let's see, 5 minus 3i is one term, and 2 plus 4i is my second term. When I add them, 5 minus 3i plus 2 plus 4i, I'm going to add my real parts, which is 5 and 2. 5 plus 2 is 7. And to that, I'm going to add my complex parts, which is negative 3 plus 4. So this becomes 7 plus I. That's just really not wanting to write, is it? What if I were to subtract these? 5 minus 3i minus 2 plus 4i. Well, I'm going to look at my real part first. This is 5 minus 2, and then it'll be plus. That's negative 3 minus 4i. So this will be 3 minus 7i. Now, what are some other operations we could do? We've done addition. We've done subtraction. We could do multiplication. To do multiplication, you usually just have to use the distributive property. Suppose I have 3i times minus 5 plus 2i. All right, I'm going to take this and distribute it to each term. So this becomes 3i times minus 5 plus 3i times 2i. So this first term becomes minus 15i. What happens to the second term? I'm going to get plus 6 times I squared. But you remember, I squared is really negative 1. So this becomes minus 15i minus 6. I want to put this in standard form, so this is negative 6 minus 15i. Now, what if I have a quadratic, or not a quadratic, but two factors? Say 2 plus 3i times 4 minus 5i. Well, I want to show you this one using the area model. You could FOIL it out, but I think this might help you a little bit. I'm going to make up my square. There we go. Now let's see if we can find the area of each of these squares. 2 times 4 is 8. 4 times 3i is 12i. 5i times 2 is 10i. And this is, what is this? 5i times 3i is 15i squared, or negative 15. Now these are going to add. So this becomes 8 plus 12i plus 10i minus 15. So when we collect our terms, I have 8 minus 15. So this is 7 plus 12 plus 10i is 22i. When you multiply like this, you're always going to get another imaginary number, another complex number. Now, what about when we do division? In general, we don't want i's in the denominator. So how do we get rid of it? If we just have one term in the denominator, then we can multiply by 1. And that 1 is I over I. So let me do that. I'm going to multiply this by I over I. Now, I'm going to distribute this. This becomes 9i plus 12i squared, where I took the I and I made sure it went to each term. I've only got one term down here, so this is 3i squared. Now let's simplify this. This is 9i. Now, 12i squared is really negative 1. So this is 12 times negative 1. All over 3i squared, which is negative 3. So let me rewrite this with the real part first. This is 12 minus 12 plus 9i divided by negative 3. And I don't mind you leaving it this way, but if you want to get rid of this negative sign, you could factor in negative 1 out of the numerator. 12 minus 9i divided by negative 1 times 3. Then those would cancel. So this would be 12 minus 9i over 3. Oh, lo and behold, we can actually do a little bit more simplifying, can't we? I didn't notice that. I could factor a 3 out of the numerator. 4 minus 3i divided by 3. So now those cancel. So this is 4 minus 3i. You always want to simplify it as much as you can. Okay, now these are fun. What do you do when you have a full complex number in the denominator? You still want to multiply by a complex number, but you want to multiply by the conjugate. How about, let's try spelling that correctly. Conjugate, C. Of the denominator. Now it turns out the conjugate of any complex number is a minus bi. Now let's look at what happens when we multiply a plus bi times a minus bi. All right, when I FOIL this out, it's a squared minus abi plus abi minus b squared I squared. So these two terms are going to cancel. And when you look at this, this becomes a squared minus b squared. So this becomes a squared plus b squared. So when I come over here, let me switch pen colors. When I come over here and multiply this, I want to multiply by the conjugate of the denominator. Now the denominator is 1 minus 4i, so the conjugate of the denominator is 1 plus 4i. But what you do to the numerator, you have to do to the denominator, and vice versa. So now let's multiply these out. We can do any method we want. Let's FOIL these. So this is 2 plus 8i plus 3i. And this is going to be minus 12 because it's 3i times 4i. So that's 12i squared. Now I'm going to go on and multiply this out, even though I could do 1 plus 4 squared and look at that and go, oh, okay, that's 17. But let's just work this one out. When I FOIL this out, this is 1 squared plus 4i minus 4i, and then it's going to be minus 4i squared. So let me simplify, collect terms. 2 minus 12 is minus 10. 8 plus 3 is 11i. Divided by, those two are going to cancel each other. And this is going to be 1, and this is going to be plus, you know what I didn't do? I didn't square that 4, did I? Somebody would have caught me. 1 plus 16, because minus 4 squared, I squared, is 16 times negative 1 times negative 1. So this becomes negative 10 plus 11i divided by 17. This is considered a simplified answer. No imaginaries in the denominator. Now the last thing we're going to do is factoring. We can actually factor over the complex plane. Let me pull a 2 out of this. This becomes 2 times x squared plus, what is this, 16. So when I factor this is a sum of squares. When I have a sum of squares, I can treat this just like I did a difference of squares over the imaginaries. Or, let me do it this way. Let me set x squared plus 16 equal to 0. So I have x squared is negative 16. Square root both sides. So x is the square root of negative 1 times 4 squared, which is I times 4, 4i. And you need to include your plus or minus. So x is plus or minus 4i. But how do I put that in a quadratic like this? Well, in factored form, this is going to be x. If 4i is a solution, then it'll be minus 4i, x plus 4i.